ready.
After you, kind sir.
Is this the latest?
Yeah. Yep.
Right, good. Right, well, this time we had this nice, I can't remember the number of it now, is it?
HC-SR04.
HCS, oh yeah. Ultrasonic range sensor.
Very popular making robots.
Yeah, very, very popular. I haven't used, but I've seen it used a lot for, literally like that infrared one we did, avoidance.
But a lot better.
But better in some respects.
Because yeah, with this, what they could do there, because set up rules, I've actually seen them done there, set up rules where if they have, say something they had over say over 100 centimetres of space in front of them, they could be going at full speed. When it goes down to 50, they slow down. So then the closer they get, the slower they get until they get to such a point they then turn. And I've seen all ones where they've like actually had that twisting as well. Or they've had multiples so they can find out like all around the front of the car how much space it's got. Definitely a good module.
Yeah, I mean it was quite intriguing to use. I should go to mine, shall I?
Go ahead.
We'll have a look at mine. I'll ignore the COM3 for the moment. Very short program. Pull in a library. There's a library for this one specifically, called New Ping. New Ping.
New Ping.
So you call that in. Then I've defined my trigger pin and my echo pin. Because the way it works, it sends an echo out.
Yeah. When it gets triggered.
When it gets triggered.
Yes.
So you trigger it, then it sends out an echo, and it times how long it takes for the echo to come back.
Yeah.
And a little bit of jiggy poke where you get some sums and it gives you the distance.
Yes.
With this also you then got to define the max distance that you want to be able to sense. I don't know what they actually can go up to. I didn't look.
Nowhere.
Perhaps that's something we can find out and let you guys know at a later stage. But then you just got the new ping statement here, which then just sets it up with the settings I've done above. You could actually do it new ping and then set things within that point to set the pins up. But I decided to separate them out. Yeah, you will drift because there's things moving about and it accents the temperature stuff moving.
Yes.
Right, anyway, then in the setup all I've done is I've just set up the serial.
Yes.
As I said, the other bit, actually the actual library actually sets the pins as if they're input output for you.
Yeah.
Which is why you see I haven't in the setup done it as I normally do. In the loop I've delayed it 50 milliseconds, so we're not doing it too quick. Gives it time for the signal to come out and come back. Then I'm just literally just printing the ping off, how the distance that I've been returned back comes back in centimetres.
Yes.
So if I was put my hand in front, you'll see the numbers drop down considerably. As I move my hand away, it starts to rise and fall. And that is it. That is simple as it gets.
Cheers. Right. Now, I will give prior warning to this one. Anyone that has any sort of stress issues or phobia of long code, look away now. Yeah, on my code, I don't have a library, basically. There is no library for the plane. So, as of such, what has happened is that the code that Dad has pre-written for himself, I had to write myself. So just quickly go through it, import the modules, set up the mode, set up the pins, disable that warning because I didn't do my new method on this one because it was such a long code anyway. Then I got my trigger, so to trigger it, it makes an output and then an input triggers an output, echoes an input, and then I define this distance, and what it does is it puts triggers to high, waits for 0.01 milliseconds, and then sets it to low, and then it detects what the start time is and what the stop time is. So what it does is it goes along, it waits whilst it has any signal back, it knows the echo's going out, and then it waits for it to come back in, and that's when it gets to stop time. It then works out the time, elapsed, and then work out the distance. So awful long code. and then I have one I still if name equals main, which again, you know, you can tell what I'm doing. If it's the main code,
yeah, you
then
drive me
it
to
tries
sleep.
it all. Yeah, it tries, works out the distance, prints the distance, and then waits 2 seconds before it goes again. So, and then like I performed my previous codes, I clean up the GPIO pins after that. So what I'll do now is work out which wires go where, and then run my code.
Right. I can quickly help you with this.
Positive.
Positive is there. It's orange. Green is your ground.
And now I need the. Let me scroll up my screen for a second there. I now need. Chuck.
Trigger.
Trigger is that one.
That's trigger.
And then echo.
Echo must be that one.
Now I am actually surprised here, so I managed to get working without any resistors. When I was looking up and I originally had problems with this module, being the fact there isn't any library, a lot of people saying, oh, you have to use resistors and all this lot. You do not, as I found out when I ran the code. And it's picking up the distance. So it's from 1 centimetres, 5.7. I mean, yeah, mine's not as quick as yours. Mine waits 2 seconds. Well, what I'm doing with that 2 second delay is I try to get the sort of like the, it's hard to say, like the fluctuation, I try to get rid of it. Sort of have it at such a point where it doesn't matter, and you know, there's not going to be as much variation between each different ones. And so what we'll do, we'll come back in a second with the code. Another code. Don't know why I said the code.
Look, we'll come back to the scoring.
We'll come back with the scoring, yes. Because what I've had to do on this one is I remember that I messed everything up and we didn't actually work out the scores before we started properly. Or did we? Yes, we did.
We did the scores, but you didn't.
I didn't update them. So if you give me uno momento.
That looks like it, doesn't it? So you've just got to change the bottom bits. Would that be no? That won't go up yet, will it?
That's why it has. Yeah, it has. Yeah, he was on 7.4 the end of the last one. I think. Perhaps. Well, no. Tom works out now. No, you this would be.
Yeah, that should be on the old.
Yeah. That's it.
But they should be the new.
Yes.
Just the way it feels about. Yeah, this was all in all was quite a nice little module.
It sure was.
And we are actually looking forward to using it again and some other time, aren't we?
Yes.
Oh, you've got issues. Well, you can see we're not professionals at this.
Yeah, so, well, they won't because most of this has been cut out. Well, if not all of it's been cut out.
Right, we just need to hurry up and get this done.
I'll do.
Fussy.
I'll do.
Well, make sure we get the scoring done properly this time. I'll give you your scores, you give me mine.
Yes. So, we just wait for the scores to load, and here we go.
There's none there.
Well, that's the end, is it?
No, it's so well, it's Arduino.
Yeah.
On style.
You gave the distance right in centimetres, right?
Yeah.
And therefore I'm giving you a 1.
But
Because I'm
after we
working
make
binary.
noises, I think yours was quite good as well. I mean, it did the distances. Right, admittedly, because you had to effectively write your own library, it was slower. But
Yeah.
I mean, with time, I think you could probably
I could have sped
speed
it
that
up.
up a bit. So I shall give you a 1 on that too.
Hey! Length of code. Use the library.
How to write a library, you're not getting a point.
Functionality. Well,
Exactly
it works
what
on both.
says. Yeah.
Ease of use.
Can you use it really easy? I mean, yeah. I mean,
Yeah, and you can on mine really, in all fairness, I think.
I think because of the length of the code, it might be a bit daunting on some people,
It
but
might
it
be a
was
bit
easy
daunting.
to use.
Yeah, basically all you have to remember is that is the time elapsed that you're working out. Now,
So the grand total scores on this one,
if I add it up correctly, is 4 and 3,
3.
which means
I win.
again, which also means you are now 3 points ahead.
Which also means,
You get to pick
I'll get the
yet
pick.
again.
let's have a look. What do we have in here this time? Oh, I did have something, then I dropped it. Oh, what's that? Got this under the close-up camera. This is a microphone.
Yes.
Isn't it? Little microphone.
With an amp on it.
With, I believe so, an amp. Yeah.
Yes. Well, that's going to be fun.
Yeah.
Wait a minute. Is it analog or digital?
Let's see if we can make you cry on camera.
No, because it won't. Aha.
Focus.
The camera's being nice to me.
Or is it?
It is.
No, I think I might be too close. Oh well, never mind. Have a look for yourself, dear boy.
It's an output.
It's an output.
It's an output.
It's an output, we don't know yet. We should find out.
In the next episode.
Yep. Right, shall we bye for now then?
Yes.
I'll stop that and you can stop the main one and then we can...
Quickly get these other two done with. I can might as well just remove the pie from the equation. There's not even have it there.